Truth tables. A truth table shows what the resulting value of a compound statement is for all the possible truth values of the simple statements. A negation. Our definition of a statement allows for the statement to be true or false, but never both. Consider the statement P equals today is Monday. If it really is Monday, then P is true, and its negation, not P, today is not Monday, is false. But if it's not Monday, then P is false, and its negation, not P, is true. The truth table for negation looks like this. Okay, so that should be pretty straightforward. So the conjunction or the and, if we have a compound statement made up of two simple statements, P and Q, there are four possible combinations of truth values for these two statements. So we have a true, 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 false, false, true, false, false. We will need to consider each statement, each combination, every time we evaluate a compound statement containing two simple statements. So let's analyze the truth of conjunctions. Let's say P is Kate has a cat and Q equals Kate has a dog. When would the statement Kate has a cat and a dog be true? Okay, so let's say that Kate is bragging to everybody about all her pets, and maybe, sometimes she overstates the fact. We would agree that she would have to have both of those items for that to be true. So if Kate just has one of those items and her statement is that I have a cat and a dog, would be false. So if she doesn't have the cat, so that P would be false, but she does have a dog, her statement is still false. If she doesn't have either one, then that would be false. Okay, the disjunction. It says, next we consider the truth table for the or statements. Again, we'll have P equals Kate has a cat and Q is Kate has a dog. When would the statement Kate has a cat or a dog be true? So I'm going to just go ahead and read this statement down here. It's important to note that in logic, as in set theory, or is inclusive. In other words, or means one, the other, or both. That's why if Kate has both a cat and a dog, the answer to the question, does Kate have a cat or a dog, is yes. She does have a cat or a dog. In fact, she has both, okay? So for that to be true, she could have both, or she could have one of those items. But if she doesn't have either one, then that would be false, right? So we have, if she has both a cat and a dog, it's true. If she has a cat but not a dog, it's still true. If she doesn't have a cat but has a dog, it's still true. She's got one or the other. But if she doesn't have either one, then it's false. All right, so you will have these truth tables available for you on the exam, but it's nice to not have to look these up every time you're doing the truth tables. So on the conjunction, you only have one true, and that happens when both of them are true. And the disjunction, you only have one false, and that happens when they're both false. So that makes it a little bit easier to remember. Okay, conditional. Now we construct a truth table for if-then statements. Suppose you place an order online and the company promises that if you pay for expedited shipping, then you'll get your order within 2 days. So let's let P be you pay for expedited shipping, and QB, you'll receive your order within 2 days. So when will the company's promise be true? You pay and you get the order within 2 days. Would that be true? You pay, but you don't get the order within 2 days. Well, that would be false, wouldn't it? Their claim would be false. Well, if you don't pay, it doesn't really matter what happens after that. Then it doesn't matter if they're, as far as their claim goes. So their claim could still be true if you didn't pay, get your order within the 2 days, true. Don't pay, don't get your order within 2 days. Their claim is still true. There's been nothing there that would disprove that statement. All right, biconditional. Biconditional statement is really the conjunction of two conditional statements. The biconditional statement, he will get an A in the class if and only if he gets an A on the final, is the same as if he gets an A in the class, then he got an A on the final, and if he gets an A on the final, then he'll get an A in the class. This means that both P implies Q and Q implies P must be true for that to be biconditional. Okay? So, in that case, if the P is true and the Q is false, it's going to be false. Oops. And if the P is false and the Q is true, it's going to be false. But if they're both false, then our result, the P, if and only if Q, is going to be true.